I'm Micah with FOAB and 9185 Robotics. This is part one of this mini series on how to use Inventor to start CADing robots and using it in the competition season. This series is specifically being made to help out the 9185 and 7865 robotics programs that I help coach. But getting posted publicly, so hopefully if this is a help for some new people wanting to use CAD for improving their robot designs and everything, hopefully this comes off as helpful. Part 0 was how to download the parts and where to find them. So I'm not going to be going over in that video. We are going to be starting in Inventor in this video. And if you are a student, you can get 1 year access by using your transcript and confirming your education status with Autodesk. You can get Inventor for free if you're a student, which I think is fantastic. So you'll want the 2025 version if you are using the CAD library that from part 0 of the series. In part 1 here, we're going to be going over how to start an assembly. Essentially, that's what you do spend most of your time in Inventor doing when CADing a robot, is putting together assemblies. And assemblies are just taking multiple three-dimensional parts and combining them into an overall mechanism. To start a new assembly, you can either use new here or general or a file new, and then we're going to create an assembly. And it'll take a moment and then load in. Like I was saying before, this is your work area. These are your parts. I'm gonna make that a little bit smaller here. And then this is your toolbar up here. The first thing you have to do when working with assemblies is to get some parts into your work area. So I'm going to use place. And this is going to take me to wherever I saved the library. We're going to use the one I downloaded in part 0 for this example. I'm going to go to the CAD high stakes. I'm going to go into my library, and this is where I can find all my parts. We're just going to go over some basic constraints. So there's a few parts I'm going to need. The first is I'm going to need a C channel. I'm going to get a 2x that is 10 long. And I'm going to click open. Now this is going to load in a C channel. Now what I can do is I can hold shift and middle click my mouse and pivot around, and then let go, and I can see it at a different angle. I can also use the scroll wheel to zoom in and out, and if I left click, it will place in that orientation. If I right click, it's going to give me more options, including to rotate around certain axes, and you can see that here the Z axis is running this direction, the Y axis is in this direction, and the X axis is in this direction. So if I rotate around the Z, it's going to put it up on its side. And I can do that multiple times if I need a different part orientation. I'm going to do this real quick. I can then right click and click OK, and I'll stop placing that part. I'm just going to go and delete that one there. So now I have two parts. Like I said, you can middle click to go left, right, up, and down. Shift middle click allows you to pivot around the center or around a part if you have it selected. So if I select this part and then pivot, it's going to pivot around the center of that part. The other thing is you do have this cube up here you can use to pivot with, or if you need to see in a flat face, you can use the orientation up here. Okay, the next thing we need to talk about when talking about assemblies is we have these parts in here, and I can go and line them up and get them pretty close. But there is a tool, as you can see in the top left here, for the relationships between parts. We can constrain them to hold them in place. Before you start constraining things so things don't spread out over an infinite space, it is going to be important to come in here, select a part, right click on it, and you're going to want to ground at least one part in your assembly at the very beginning. That gives you something that can't move or something you can't drag around. I can still move around it, and I can move the other parts. But this means when I start constraining other stuff to this, it will hold it in place. If not, I could be able to move the whole assembly, and you can run into some issues later when you get into more complex assemblies. So ground it, it just holds it in place. So with constraints, click constrain, or you can click C on your keyboard. And the most common type is you're going to use this mate. And there's two options. There's flush and there's mate. Mate allows me to take two faces of two different parts and mate them together. Now what that does is it holds those parts, that flat edge, touching each other. I can move it around on, but those two things are constrained in that way. If I go back into constrain, I can then take this flat edge, and I'm going to click on flush. Then I'm going to take the flat edge of this hole on this C channel, and I'm going to constrain that flat. Now, what I've done is I've constrained the two flat outside parts, and I've constrained these holes in line. So that allows me to move it up and down. General rule of thumb, to get something to not move, you need to constrain it in at least 3 different directions to stop it from moving at all. So my third and last direction, and now this is where the Vex Cad library and why I used it as the base of the library I plugged in episode 0, is they've included these transparent holes that you can constrain to. It actually makes it pretty easy to constrain pieces of metal together and other circular objects. If you click on a circle, it'll highlight with this dashed arrow line down here in the middle. If I click on that, what that allows me to do is I can also constrain to another circle. And that's going to line up those axes. Now, I'll show you that in a minute, but it just lines it up nice and perfect. And now, even though this part is not grounded, it cannot move either. So those are the 2 or 3 most basic constraint options. We'll go over some more advanced ones here in a few videos' time. The one last thing I will show is, like, for if we're doing something with wheels or you're doing something with a spacer of some sort. Actually, let's do this with gears. I'm going to do a low strength gear, and we'll choose a 60 or 36 tooth gear. If I have a gear here, you may have this square insert on the middle here. If I need to constrain this to this middle hole here, it may be complicated to constrain a square hole to this circle hole here. Well, one thing to keep in mind is I can select an outside circle. I can even select this outside circle here, but the axis stays the same. It goes right through the middle. I can then select this. What that does is it constrains those axes together. Those axes are always going to stay in line, and this will spin, but it can move left and right. If I'm in this orientation, it can still move left and right. So the last thing I can do, come here, grab this, constrain it to that. And now I've only constrained it twice, but that's because I haven't constrained it from spinning. With those 3 constraint options, you can pretty much CAD the basics of any robot. We'll get in, like I said, we'll get into more advanced constraint options in a later video.